Hi, welcome to Sunil Maths tutorial, Fourier series, class number 8. Let us see a problem. Expand the function f of x is equals to x square as a Fourier series in the interval minus pi to pi, and also show that, hence deduce that following conditions. So there are three different conditions, you have to derive them. Let us see. So they given that the function f of x is equals to, they given that the function f of x is equals to x square. The function f of x is equals to x square. So it is very clear, f of minus x is equals to minus x whole square, it is equals to x square, it is equals to f of x. What it means? F of minus x is equals to f of x. This is true for all x. Therefore the function f of x is even. The function f of x is even function. If the function f of x is an even function, then obviously the Fourier series of f of x is simply given by f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx. For even functions, this is the Fourier series. So here again, that a naught is given by the formula a naught is equals to 2 by pi integral 0 to pi f of x dx, and that an is given by the formula 2 by pi integral 0 to pi f of x cos nx dx. Now we find these two values. Let us see the first one. a naught is equals to 2 by pi integral 0 to pi. What is f of x here? x square dx. Integral x square is nothing but x cube by 3, and the limits are 0 to pi. Lower limit is 0, so no need to substitute, only upper limit 2 by pi cube by 3. This is simply 2 by 3 pi square. Therefore a naught is equals to 2 by 3 pi square, or 2 pi square by 3. 2 pi square by 3. This is a naught. Go for an. This an is given by the formula 2 by pi integral 0 to pi f of x cos nx dx. So you can write 2 by pi integral 0 to pi f of x square cos nx dx. What is the Bernoulli's principle? The Bernoulli's principle is given by integral uv dx is equals to u v1 minus u dash v2 plus u double dash v3 minus and so on. Here u is equals to x square. What is u dash? 2x. What is u double dash? 2. What is u triple dash? 0. v1 is equals to cos nx. v2 is equals to 1 by n sin nx, and v2 is equals to minus 1 by n square cos nx. v3 is equals to minus 1 by n cube sin nx. You have to multiply in this order. You have to multiply in this order. Okay, so this integral becomes 2 by pi uv dash x square 1 by n sin x square 1 by n sin nx minus, in the formula we have minus, but already here also we have one more minus plus 2x 1 by n square cos nx. In the formula we have plus, but we have here minus, so minus 2 by n cube sin nx. Limits are 0 to pi. So now you observe that. Here everybody knows that Sin pi is 0. Sin pi is 0. Sin n pi is equals to 0 for all n belongs to z. So by using that two conditions, this first term and the third term completely becomes 0. First and third terms completely become 0. You get only second term. So 2 by pi 2x by n cos nx and limit 0 to pi. Again, if you substitute the lower limit 0 here, if you substitute the lower limit 0 here, obviously the second term is 0. So you get only upper limit, you get value only for upper limit. So 2 by pi, 2x means 2 pi by n cos n pi. Again here, this pi get cancelled. You get 2 2s are 4 by n. 4 by, I'm sorry, this is n square I think. Yes, you are right, n square. 4 by n square cos n pi minus 1 power n. Cos n pi minus 1 power n. So this is the value of an. An is equals to 4 by n square minus 1 power n. This is an. Already we find the value a naught 2 pi square by 3. Already I write the Fourier series is there. F of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx. So I substitute both. The required Fourier series is the required Fourier series is f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx. What is f of x here? X square a naught by 2. So here it is a naught. So if you write a naught by 2, you get pi square by 3. So pi square by 3 plus summation n is equals to 1 to infinity. Here it is a n 4 by n square minus 1 power n cos nx. This is the required Fourier series. Remember that. This is the required Fourier series. In the problem we have, there are some series. You see there, you have to derive these three conditions. You have to derive 1 by 1 square minus 1 by 2 square plus and so on, 1 by 1 square plus 1 by 3 square plus and so on, 1 by 2 square plus 1 by 3 square plus and so on. So to derive all these conditions, we can use different values of x. If you remove the summation here, you can get x square is equals to pi square by 3 plus 4 into pi square by 3 plus 4 into, you get minus cos nx by 1 square plus cos, not 1x, cos 1x, for 1 it is 1x, cos 2x by 2 square minus cos 3x by 3 square plus cos 4x by 4 square and so on. By making minus common, x square is equals to pi square by 3 minus 4 into cos x by 1 square minus cos 2x by 2 square plus cos 3x by 3 square minus cos 4x by 4 square minus and so on. This is the required series. So right, now derive the conditions by using different points. Put x equals to 0. Put x equals to 0 in this one. Put x equals to 0. If you put x equals to 0, the left side becomes 0. The right side is pi square by 3 minus 4 into, everybody knows that cos 0 degrees is equals to 1. So you get minus 4 into 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square and so on. So this is simply pi square by 12 is equals to pi square by 12 is equals to pi square by 12 is equals to minus 1 by 1 square plus 1 by 2 square. I'm sorry, you have to open the bracket. So like this, minus plus 1 by 3 square minus 1 by 4 square and so on. So you can write like this after x equals to 0, after simplifying by here also you get 1 minus. So minus minus get cancelled. You simply pi square by 12 is equals to 1 by 1 square plus 1 by 2 square, not plus, this is minus, plus 1 by 3 square minus 1 by 4 square plus and so on. This is the required one of the series. If you put x equals to 0, you get this. Now put x equals to pi in the series. Put x equals to pi. If you put x equals to pi in the Fourier series, left side x square becomes pi square. The right side becomes pi square by 3 minus 4 into cos pi minus cos 2 pi by 2 square plus cos 3 pi by 3 square minus cos 4 pi by 4 square plus and so on. This is the Fourier series. So by substituting these, you can write pi square minus pi square by 3 is equals to minus 4 into cos pi minus 1. Cos 2 pi, what is cos 2 pi? 1 minus 1 minus 1 by 2 square minus 1 by 3 square minus 1 by 4 square plus and so on. So you simply get 2 pi square by 3 into 4 is equals to minus of minus everything becomes plus. Minus of minus everything becomes plus. So you get this 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus and so on. 2 ones are 2 twos are. So you simply get this series becomes 1 plus 1 by 2 square plus 1 by 3 square plus and so on is equals to pi square by 6. Pi square by 6. This is the required second series. So here you remember that some values of cos pi, cos 3 pi, cos 5 pi and so on is equals to minus 1. Cos 2 pi, cos 4 pi, cos 6 pi and so on, these are equivalent to plus 1. So remember that. And then the last one, to derive the last series. Now we have two different series. You observe that we have two different series. The first series is 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus and so on is equals to pi square by 12. The second series is 1 plus 1 by 2 square plus 1 by 3 square minus 1 by 4 square, not minus, plus 1 by 4 square plus and so on is equals to pi square by 6. Adding these two series, if you add these two series, even terms get cancelled. 1 plus 1, 2 plus 2 into 1 by 3 square plus 1 by 5 square plus and so on is equals to pi square by 12 plus pi square by 6. So by making 2 common here, 1 plus 1 by 3 square plus 1 by 5 square plus and so on is equals to, here LCM is 12, pi square plus 2 pi square, 3 pi square by 12. So finally we get 1 plus 1 by 3 square plus 1 by 5 square plus and so on is equals to 3 pi square by 24. 3 ones are 3 eights are. You simply get pi square by 8. Pi square by 8. This is the required third series of the Fourier of the problem. So So that's it. Keep learning. Wish you all the best. In this video, we learn different forms and different integrations. Bernoulli principle is there. You practice it and you have to learn some standard values. Sin pi 0, sin n pi 0, cos n pi is equals to minus 1 power n, and you have to learn this cos pi, cos 3 pi, cos 5 pi, and these values differentiate them. This is minus 1 and this is plus 1. Keep learning. Wish you all the best.